All right, we're going to discuss what claim, evidence, and reasoning is and how to make a concept map, two things you'll be using extensively in the class. So first off, let's talk about arguments versus explanation because those two usually are confused. When you're making an argument, you're basically discussing something that's unsettled, a piece of information or idea that's not completely agreed upon by two different people. You don't necessarily want to have an argument over something you both agree on. I mean, that'd be pointless. So it's important to understand it's something that's unsettled, something that you don't agree on. Your goal in this is to try to persuade the person. You make an argument because you're trying to persuade them to believe you are right and they're wrong. You don't just sit there and summarize your view, you try to make an argument for it. It's made up of questions, claims, and evidence. Obviously, questions in the form of you're trying to ask them their counterpoints. You make your claim, your statement that basically why you believe whatever you do, and then the evidence to support that. Explanation, on the other hand, deals with settled knowledge. This is what you typically use when you're trying to summarize something, like if you're taking your notes and then you want to summarize it, you're doing an explanation, you're not doing an argument. You're not trying to argue about the validity of your notes, you're just sitting there trying to correlate them into a smaller amount of information. Your goal here is to inform others, you're not trying to persuade them. An example is your summary. So let's first talk about the claim for claim, evidence, and reasoning, which is also known as CER. Your claim answers a question. So whether I give you a question or a question comes up in a laboratory or any other situation, your claim is basically the answer to it. It should be no longer in a single sentence. You don't want to get too wordy. You don't need to sit there and write a paragraph about just your claim. You want to save that space for your evidence and your reasoning for your claim, your backup. So what is evidence? Evidence is all the scientific data that supports your claim. Now, this could be from your book, this could be from your notes, this could be things that you know, anything that supports your claim, whatever that is. Evidence must support the claim and can come from text, data, internet. As long as it's a valid source, you're more than welcome to use it. All right, the hardest part is the reasoning. So most people can make a claim, most people can provide evidence for the claim, but reasoning for why that evidence is important for that claim is the harder part. And that's the part that's going to take you a little longer to develop. So basically, reasoning is the explanation that connects your claim to the evidence that supports it. So it's basically trying to explain why that piece of evidence is important to that claim. You're trying to argue about why you're including that piece of evidence. What's the validity of it? Shows what the data you chose counts as evidence using scientific principles and follows each piece of evidence. So after you make a claim, you provide the evidence, provide the reasoning for that evidence, provide another piece of evidence, another reasoning. So your typical format for one of these things is going to be you make your claim, provide evidence, reasoning why that evidence supports the claim, another piece of evidence, and the reasoning for why that piece of evidence supports the claim. That's the minimum. In any typical argument or anything you're doing in this class, this is the minimum sequence: claim, evidence, reasoning, evidence, reasoning. I don't want you to sit there and do claim, evidence, evidence, and provide reasoning all at the end and backload it. I want you to provide the reasoning after each piece of evidence because that shows me that you understand what the significance of evidence is to your claim. So be aware of that. You could provide another piece of evidence and reasoning as well. That's wonderful if you can come up with it, but at minimum, you're going to be required to do this sequence, at least for the class. All right, so now let's talk about concept maps. A concept map is basically a way of organizing information. It's a visual representation of information. It's designed to make a large piece of information into a smaller visual format so you can digest it better. It's not supposed to be a recopy of your notes. And when you're taking notes using concept maps, I don't want you to write everything you see. I want you to paraphrase as much as you can, eliminate pieces of information that's not really valid or important, or that you already know. Like if I tell you the sun is yellow, you already know that. Do you really need to include that as part of your notes? No, it's pointless. So you want to make maps that include only pieces of information that are either really relevant or that you didn't know. So here's your usual sequence. So let's say you're taking notes, and for most notes, you're going to be given S1s that you could use. At the beginning of the notes, there'll be a list of optional S1s, and I'm trying to guide you in the beginning to help you understand how to do it. So in a single set of notes, you may have 2 or 3 S1s. So it's not just one circle with a whole bunch of stuff around it, like a normal concept map. What I want you to do is find the main topics in a set of notes, typically no more than 3, that's the norm, And then you put that in the middle. That's your S1. The shape you take for that is an oval. So an oval represents S1. So whenever I see ovals, I'm assuming it's an S1. So be aware of that. So let's say, for example, you're doing something about the periodic table. So periodic table could be your middle. That's what you put as your S1. Your S2s are basically details about whatever your S1 is. So in the case of periodic table, you could talk about how there's rows called periods. Here you could talk about how there's columns called families. Here you could talk about there's metals, and you could go on to talk about non-metals, and here you could talk about metalloids. I mean, it's really up to you. It depends on the notes and what's involved. But the point is there should only be one S1, and the S2s can vary. You could have 2, 3, you can even have 1 sometimes. Really, there's no set amount necessarily. But what you're trying to do is basically organize the notes into this format. So in a typical set of notes, you may have 3 of these maps. So that usually fits 2 on one page of your notes and then the third on the back. So I don't want you to condense everything. I've seen students do this little thing where they have like them on top of each other. Don't do that. Give them some space. If it looks too chaotic, your mind's not going to be able to digest it or register it, and you're not going to use it. It's going to be pointless. I don't want you to take notes in this format and then never look at it. It will be a waste of both of our times. So next to the S2, you have extra information or example. So if you're talking about, rows, you could say there's 7 periods in a periodic table, 7 rows. That's an option. It's just basically more information, or you could put an example, everything necessary. You could put as many of these as you want. And the format for these are bullets. So once again, oval is the main topic. You typically have about 2 to 3. Square is details based off of this main topic, whatever it is. And then bullets that either are extra information or examples. So S1 is the main topic that is built around, the whole map is built around. It's a key concept we want to know more about. Your S2 is detail about the main topic, represented by a square or a rectangle, whatever you want to call it. S3 is extra information for example of S2 or an example of S2, and the usual format for that is bullets. So those are the different components of it. So let's take a look at an example of a concept map. So after completing your map, come up with 2 or 3 questions. So after you finish building your map, what you want to do is have this little component. You want to have 2 or 3 questions about your notes. The reason you want to do this is because you want to get, not instead of being passive in your note taking, you want to be interactive. You want to engage with your notes. The most common mistake students make is that they have passive note taking. They'll take notes, don't really digest it, don't play with it, don't think about it, and then they wonder why they can't remember any of it. Your mind needs that processing time. The best way to do that is to ask questions. So at the end of each concept map, so you have 3 maps on, for one set of notes, you're going to sit there and write 2 or 3 questions you have regarding those notes. And then a summary is basically a concept that involves writing each major concept in the middle of your map and then adding major and minor details about that topic. That's the whole point of a concept map. That basically puts everything to a nutshell. One other thing about the questions thing, if you really are good as far as being able to register information you write, another thing you can add after the questions is a little summary. Summarize your notes. It's totally optional, but that's another thing you can incorporate if you find that it helps you digest the information. You're going to have to play with different tools until you come up with whatever works for you. But what you will realize about the concept map is that after you build a few of them, that it does condense all the information in a smaller, more digestible amount, and you'll be able to process a little bit better, especially if you're a visual learner. This will be definitely up your alley if you do it. So the minimum map is called an S1, which is major idea from unit of study. And your S2s and S3s are basically details and minor details from that. So let's take a look at an example of one. All right, atom was the S1, so that's the major topic. So what do we know about atom? It has a nucleus that's made up, that's in the middle and makes up all the mass. You have 2 major models about it. Electrons orbit and rings around some nucleus. So these are 3 things I picked up from the notes. Whether it's a book or whether it's the notes I give you, any of those situations, these are the 3 pieces of data I think are important based off of the atom. So for the nucleus in the middle, notice I could just write what that concept is, or I could put a little more detail. I could say the nucleus in the middle makes up all the mass. That's a lot of detail, right? Whereas here I just say 2 major models. I don't indicate what the models are. It's up to you to decide which style works better for you, putting some info in there or leaving it just a concept. So here I include some minor details about it. So we know there's a proton in a nucleus and has mass 1 AMU, neutrons mass 1 AMU. And wherever discovered a positively charged nucleus, these are all the important things I came up with regarding the nucleus, and I include it as my S3s. Here, same thing on the bottom. I have electrons masses 0 AMU. 2 electrons can be in the first ring, 8 in the rest, discovered by J.J. Thomson. These are all the important details I was able to get from my notes. They're not all necessarily in the same location of my notes, but these are the important details I figured out from the notes about the electron. And 2 major models are the plum pudding model with no nucleus, nuclear model with nucleus and electrons orbiting the nucleus. So these are the important pieces of information I want to know about these models. Please don't skimp on details, but also don't go overboard. Don't sit there and write every piece of information you see on your paper because it gets too congested. Get to the point, include what's important, use short-term things like W/, whatever system you have. You can use text speak, it doesn't matter. Whatever you're able to digest without having to write too much. You want to minimize the amount of writing you do, not maximize it. That's the whole point of these maps. So here's my 2 questions. What is the current view of the atom? That's a good question because there's 2 models. So what do you think about the atom now? Do atoms have protons, electrons, neutrons? Not a good question. Does everything have protons, neutrons, and electrons? So that's what you're looking at for questions. And that's how we do our concept map, and that's how we do our CER.